Some quick notes here on 7.1, which is our beginning of ArrayList. ArrayList, like arrays, we're looking to manage large amounts of data. A little bit different in a few aspects, though. One of the things that we'll see is that ArrayList can only hold object references. So that's going to rule out any primitives. So you can't have, basic type int, double, or Boolean. However, we'll see with autoboxing that that's not that big of an issue anymore, but we will notice a few things with like our wrapper classes here. Two important things. ArrayList are mutable. So unlike arrays, it's actually really easy to change the dimension of an array list. If I want to add items to it or remove, there's specific methods for both of those actions, and it's very easy. So anytime you're storing data that you think the size of the data set might change, probably want to plan on using an array list. We saw how difficult it was to change the size of an array. And ArrayList can obtain object references. So as I mentioned, no direct access to primitives here. So I'm going to show you a few things about ArrayList, and some of these are now outdated. So if you looked at like an old Barron's guide or old AP test questions, you might see an ArrayList created like I'm showing here. This ArrayList does not have a specific type, and it can hold any type of object reference at the same time. So with our arrays, we had to say up front, was it going to hold strings? Was it going to hold ints? Was it going to hold rectangles or a person or a store item? An array list could actually hold references to all of those types of things at once. So this is, calling on the basic ArrayList constructor. See here, new ArrayList, so we're creating new memory that's going to create a reference to this array list. It's going to be held by list one. So this is very, very similar to how an array variable can hold a reference to an array. This holds a reference to an array list. If we print, one kind of neat thing about ArrayList is that it has a toString. So instead of getting like a weird memory address, right here, this would actually just print like two brackets. So not too exciting yet, but instead of getting that weird memory address, at least we are getting sort of a visual representation of the storage that this has. And we're going to get into the methods of ArrayList in the next video, but just real quickly, there is a size method, and that kind of replaces our dot length that we used with our arrays, and dot length as a method that we've used on strings. Same idea, it's going to tell you how many items are in there. These are indexed just like arrays, starting at 0, however the size is overall size. As I mentioned, this array list could hold anything, and there is that autoboxing thing. So even though I said that array lists can only hold references and they're not built for primitives, if we used primitive doubles like B and C here, you could add them to the array list because of autoboxing. Before autoboxing was available, you would have actually had to have declared these as their wrapper class counterparts. So like this would have had to have been an integer, and this would have had to have been a capital B double. That's not necessary now because of autoboxing, but that is technically what's happening on its way in. It's being autoboxed, and then a reference to that is being held, not the actual value. If we look at here, I've done something different to list 2. Okay, and this is how we're going to do ArrayList in our course. As I mentioned, this is sometimes called like an untyped or generic type array list. It can hold any type of reference. We won't see those on the AP exam anymore. Every array list we see on the AP exam is going to only hold objects of a specific type, and that type will be declared at the instantiation of the array list. So this is holding only type double references. Now, if I tried to add things like A, which you might remember was a string, or C, which was an integer, those would all be rejected. So right now, if I run this program, everything should be legal. I've commented out lines that cause errors. I'm getting some warnings. Okay, those warnings may be dealing with things for like the fact that my array list wasn't typed okay, up here in line 35. But again, we're not going to see that on the AP exam, so we don't have to worry about it too much. If I remove this comment here, I would not be able to add a, which is a string, into ArrayList 2, which only accepts doubles. I was able to add a string and an int and a double to list 1 because I didn't type it, but now I have an incompatible types error, okay? So when an ArrayList has been typed, it can only hold that type of object. Notice that this syntax is pretty different than anything we've seen so far, right? A lot different than creating like a double array. I don't think we've really ever used like the whole less than, greater than. We're going to learn more about this. This is commonly used in Java, and I'll talk a little bit about that more later. If we look at some more things that I've got here, again, if you notice, like in line 60, I got a little careless here. I tried to create an array list out of a primitive double. That's illegal. Okay, so like I mentioned, array lists only work with object references. So I was very careful in line 54 to use a wrapper class double, not a primitive double. Wrapper class doubles are legal to make an array list out of because they are running on object references, okay? But you can't use a primitive. You might notice right here, I printed list 1. That was after I added the 3 items to it, the string and the double and the int. So again, it's kind of nice. There's like this built-in toString that will make a nice representation of it for you. In the olden days, okay, when we used generic type lists like list 1, we had to cast everything on the way out of the list because since the list could hold a string and a double and an int all at the same time, you didn't really know what was coming out of it. So you had to say like at that moment what it was. So when I get something from the list, like in this case, I was trying to get the 6.54 from index 1, then I had to say that it was a double, okay? However, if I'm using a typed list like list 2, which only holds doubles, then I don't have to bother and say, that it's a double because it's already known. Since the list could only hold doubles, then anything coming out of it has to be a double. And this is also an example of auto unboxing here. So even though the list was holding wrapper class doubles, on the way out, it was auto unboxed and I could put it into a primitive double. That might sound scary, but really it's not a big deal. Okay. And again, ArrayList E is preferred over ArrayList because it allows the compiler to find errors that otherwise would be found at runtime. So if you're not using a typed ArrayList and you're relying on like specifying things coming out, well, sometimes you get in trouble because like this line of code right here, you might notice I haven't had this commented, so my program's been running the whole time, but I've been getting this error at the end. The error was actually showing up at runtime, not at compile time. That's why my code was running. The error was happening in line 81 because remember the item at 1 in list 1 was a double. I had declared that it was going to be a string on the way out, like I was casting it to a string. And a weird thing then, the compiler let my code run. It basically trusted my judgment to say, oh yeah, this is a string. He knows what he's doing. But I didn't know what I was doing because it was really a double. And then it figured it out when it got there, and it reached line 81 during the runtime. Runtime errors are usually harder to debug than compile errors. That's what, we don't really like these. So if I was using a typed list, I would have known this ahead of time. Like it wouldn't have come down to this. That's why we typically use a typed list. If you'd like to read more about this whole mysterious letter E thing here, it's called a generic type, and you can read a little bit about it on CS Awesome, or I'll give you a link. I should have put in this video. I'll link it into the notes when I post it.